In this video, we will learn how to describe the components of electrolytic cells and predict the products of the electrolysis of molten salts. This video is about the electrolysis of molten salts. The electro means we're using electricity, and lysis means separation. What are we separating? Well, molten means that something has been heated up to its liquid state. And a salt is another word for an ionic compound made up of positive and negative ions. During electrolysis, we will use electricity to separate these two types of ions. Let's take a look at the electrolysis of lead-2-bromide as an example. In its solid state, the ions in lead bromide are bonded to one another and cannot float freely. If we heat it up so that the solid reaches the molten or liquid phase, the ions will no longer be bonded to one another and instead float freely in the liquid. In fact, a sample of molten liquid lead-2-bromide contains only lead ions and bromide ions floating around to make up the liquid. When we heat lead-2-bromide to the liquid phase, it becomes an electrolyte. An electrolyte is a substance made of ions that can conduct electricity. Electricity is the flow of charged particles. So liquid lead-2-bromide with its free-floating ions can conduct electricity, while solid lead-2-bromide with its bonded ions cannot. We could also turn solid lead-2-bromide into an electrolyte by adding water to create an aqueous solution. We will learn about the electrolysis of aqueous salt solutions in another video. The electricity in electrolysis comes from a battery or another similar power source. The battery is connected by wires to two electrodes, usually made out of an inert substance like platinum or carbon. With an inert electrode, electrons can pass through the electrode without the atoms of the electrode taking part in the reaction. We will sometimes see a battery diagrammed like this, as two parallel lines connected to the wires. The longer parallel line represents the battery's positive terminal, and the shorter parallel line represents the battery's negative terminal. During electrolysis, when the circuit is turned on, the negative ions, also known as anions, move to the positive electrode. The positive ions, known as the cations, move to the negatively charged electrode. In fact, the names of the electrodes and the ions that are attracted to them correspond to one another. The anions are attracted to the anode, and the cations are attracted to the cathode. Soon after turning on the circuit, we will see a brown gas bubble up at the anode and waft up into the air. In addition, we will see a liquid, silver-colored metal bead form beneath the cathode. What is going on to produce these two substances? Well, the bromide ions gather at the anode. At the anode, each bromide ion donates an electron. A pair of bromide ions can donate their electrons and then come together to form a bromine gas molecule. That brownish gas that we see is bromine gas. The half reaction for this process is two bromide ions produce a Br2 gas molecule and two electrons. The electrons donated by the bromide ions flow through the wire to the cathode. The lead ions gather around the cathode. There, each lead ion is able to accept two electrons, turning into a solid lead atom, which then sinks to the bottom of the vessel, forming the silver-colored liquid bead. The bead is made of molten metal lead. The half reaction for this process is a lead ion plus two electrons produces lead. Overall, this is the process of electrolysis. Electricity separates the positive ions and the negative ions, which then form new products at the electrodes. We sometimes refer to electrolysis as the decomposition of an electrolyte using electricity. To put this in simpler terms, it means the breaking down of a substance that conducts electricity. In our example, we broke down lead bromide to form lead and bromine gas. If we had instead electrolyzed aluminum oxide, the products would be aluminum and oxygen gas. We can extend this pattern and say that for the electrolysis of molten salts, the products will be the elemental form of the cation and the anion. The cation will tend to form a metal, and the anion will tend to form a gas. Earlier, we wrote down the chemical equations that show what is happening at each electrode. At the cathode, a lead 2+ ion combines with 2 electrons to form lead. At the anode, 2 bromide ions form Br2 gas and 2 electrons. These chemical equations might look a little different than the ones we're used to seeing because they are half reactions. Half reactions show the formation of one product and the electrons involved. There are 2 main categories of half reactions. Either the atoms or ions gain electrons, or the atoms or ions lose electrons. For the reaction on the left, the lead ion gains electrons to form lead. In the reaction on the right, each bromide ion loses an electron during the formation of bromine gas. When the atom or ion gains electrons, we call this a reduction. In this case, the lead ion is being reduced. On the other hand, when an atom or ion loses electrons, we call this an oxidation. The bromide ions are being oxidized to form bromine gas. Because the full reaction here is the combination of a reduction half reaction and an oxidation half reaction, we call this full reaction an oxidation-reduction reaction. While this oxidation-reduction reaction describes the entire electrolysis, each half reaction gives us some extra information about what's happening to the electrons at each electrode. During electrolysis, electrons flow through the wire from the anode to the cathode, where they are donated to ions. So the reduction half reaction, where an ion gains electrons, will occur at the cathode. Conversely, since ions give up their electrons at the anode is where the oxidation reaction takes place. If we have trouble remembering the definitions of oxidation and reduction, there's a handy acronym we can use: OIL-RIG. Oxidation involves a loss of electrons. Reduction involves a gain of electrons. Another acronym we can use is Leo the Lion says grr. Lose electrons oxidation, gain electrons reduction. As a summary, during electrolysis, one ion will gain electrons and be reduced at the cathode. The other ion will lose electrons and be oxidized at the anode. Now that we've learned about the electrolysis of molten salts, let's do some practice problems to review. In the electrolysis of molten lead bromide, shown in the picture, which electrode is on the right? A. The cathode, as it is oxidizing the bromine. B. The cathode, as it is reducing the bromide ions. C. The anode, as it is reducing the bromide ions. D. The anode, as it is oxidizing the bromide ions. Or E. The anode, as it is oxidizing the bromine. This picture depicts the electrolysis of molten lead bromide with a brown gas wafting up from one of the electrodes. This brown gas is bromine gas. This question is asking us to describe how bromine gas forms and at which electrode. Each choice has 3 parts, meaning there's 3 pieces of information we need to gather in order to answer the question. Is bromine gas produced at the anode or the cathode? When bromine gas is produced, does it involve an oxidation or a reduction? And does that oxidation or reduction happen to bromide ions or bromine atoms? Let's start with the 3rd piece of information. Does this process involve bromide ions or bromine atoms? Molten lead bromide is made up of free-floating lead ions and bromide ions. Electrolysis requires an electrolyte. An electrolyte is a substance made up of ions, or able to release ions that can conduct electricity. When the circuit is turned on, the bromide ions are drawn to one of the electrodes to begin the formation of bromine gas. Since the reactants in this process are bromide ions and not bromine atoms, we can eliminate choice A and choice E from consideration. Next, let's consider the name of the electrode. The negatively charged bromide ions are known as anions. This is in contrast to the positively charged lead cations. Which electrode, the anode or the cathode, are anions drawn to? Well, we can remember that their names correspond with one another. Anions are drawn to the anode, and cations are drawn to the cathode. In this example, bromide anions are drawn to the anode, so we can eliminate choice B from consideration as well. The last question to consider is whether these bromide ions are being oxidized or reduced at the anode. Let's take a look at what happens to the bromide ions at the anode in order to answer this question. First, each bromide ion donates an electron to the anode. Then, the ions that have donated their extra electrons can pair up to form a bromine gas molecule. The half reaction for this process is 2 Br- ions produce Br2 and 2 electrons. With this process in mind, are the bromide ions being oxidized or reduced? In this situation, since the bromide ions are giving up or losing their electrons, it's an oxidation. On the other hand, a reduction is when an atom or ion gains electrons. For example, at the cathode in this experiment, the lead ions will gain electrons or be reduced to form elemental lead. Since the bromide ions are losing electrons or being oxidized, we can identify D as the correct answer. The electrolysis of molten lead bromide produces the brown bromine gas as a product. The bromide ions are attracted to the anode, where they donate electrons to form bromine gas. Since the bromide ions lose electrons, we also call this process an oxidation. So, in the electrolysis of molten lead bromide, shown in the picture, which electrode is on the right? That's choice D, the anode, as it is oxidizing the bromide ions. Barium metal can be obtained through electrolysis of its molten salt. Which of the following equations shows the reaction occurring at the negative electrode? A. Barium plus 2 electrons produces barium 2+. B. Barium produces a barium 2+ ion plus 2 electrons. C. A barium 2+ ion plus 2 electrons produces barium. D. A barium 2+ ion plus 2 electrons produces 2 barium atoms. Or E. A barium 2+ ion produces barium and 2 electrons. This question is asking about the electrolysis of a molten salt. This process occurs when we dip 2 electrodes connected to a battery into the liquid form of a salt. The liquid salt is made of free-floating positive and negative ions. In this question, the positive ions, or cations, will be barium ions. The identity of the negative ions isn't important to answering the question, so let's just use chloride as an example. When the circuit is turned on, the ions will be attracted to the electrodes of the opposite charge. When the ions reach each electrode, a reaction will occur. This question is asking, what happens to the barium ions on the surface of the electrode, shown here on the left? Each choice is essentially the same 3 pieces of information rearranged. In order to answer this question, we need to ask, when are barium ions present? When are barium atoms present? And are electrons absorbed or released during this process? Let's look at the wording of the question for some clues about what's going on. As we've just explained, a molten salt involves ions, and the electrolysis of a molten salt starts with ions. Similarly, if we are trying to obtain barium metal, that must mean that the atomic form of barium is a product of the reaction. That means we can eliminate choice A and B from consideration. We want the ion to be on the left side of the equation as a reactant, and the atom to be on the right side of the equation as a product. We know that barium metal will form as a product of the reaction. It will do so by plating on the electrode. Our next question is, what is going on with the electrons to make this happen? In electrolysis, electrons flow from the anode to the cathode. They are taken from the ions at the anode and given to the ions at the cathode. In our example here, the electrons at the cathode are donated to the barium 2+ ions. The 2+ charge of the barium ion and the combined 2- charge of the 2 electrons balance out. As a result, barium metal atoms form. We can simplify this process by saying that the barium ion has gained electrons to form the atom. Choice E, where electrons are a product of the reaction, is the opposite situation, where electrons are released from the ion. We want the electrons to combine with the ion to form the atom like they do in choice C and D. The last thing we need to consider is whether the combination of a barium ion and 2 electrons would produce 1 barium atom or 2 barium atoms. Simply put, the correct answer is choice C. 1 ion combines with electrons to form 1 atom. This reaction describes what occurs at the negative electrode when we electrolyze a molten salt containing barium. The barium ion will gain 2 electrons to form a barium metal atom. When an atom or ion gains electrons, we call that a reduction. Electrolysis is one way to isolate pure metals. In fact, barium was first isolated by British chemist Sir Humphry Davy in 1808 when he electrolyzed molten barium oxide. So, when we obtain barium metal through electrolysis of its molten salt, the equation that shows the reaction occurring at the negative electrode is choice C. A barium ion plus 2 electrons produces a barium atom. Now that we've done some practice problems, let's review the key points of the lesson. Electrolysis is essentially the electrical separation of ions, and a molten salt is the liquid form of an ionic compound. A molten salt is comprised entirely of free-floating positive and negative ions. The products of the electrolysis of molten salt will be the elemental forms of the ions present. Typically, the cation will form a metal, and the anion will form a gas. When the circuit is turned on, the negative anions will flow to the electrode, known as the anode, where they will give up their electrons. When an atom or ion loses electrons, we call this oxidation. Conversely, the positively charged cations will flow to the cathode, where they gain electrons. The process of gaining electrons is known as a reduction. Lastly, half reactions show the formation of one product and the electrons involved. For example, the half reaction that shows the formation of lead is a lead 2+ ion plus 2 electrons forms lead.